This week, we'll continue working with our wind data and learn how to plot windroses as inset axes on an OpenStreetMap using CartoPy. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for NSF Unidata. If you remember on last week's MetPy Monday, we got to this 4-panel plot of 4 different stations making windroses and seeing that there were some interesting patterns, namely that we had largely southwest winds at one station, north-south winds at one, north winds at one, and northwesterly winds at one. So it'd be handy to plot these on a map so we could see what's going on geographically that might be causing these patterns. If you need a quick recap, go and check out last week's MetPy Monday, but the short version is we read in data from ASOS using Pandas read CSV, and then using the Windrose axes object, we're able to make these nice windroses, and we just did a simple 4-panel subplot. But now I want to make this on a map. So the first thing that I need to do is get station information in terms of location. If I look at the head of my data frame, you'll see that we have longitude and latitude of each station in the data frame. So let's create a locations dictionary. So we're going to create an empty dictionary, and then for station in our stations list, I'm going to get data frame, or the data frame station data series is equal to our station name. And then using iloc, I'm going to get the first instance. So this just gets the first instance of each station occurring in our data frame. In our locations dictionary, using the key of the station name, I'm going to assign that to have a value of a list, the station row longitude, station row latitude. So if we look at our locations now, we see that we do indeed have a dictionary where the key is the abbreviation for the station and the value is the longitude-latitude pair, or the XY value. That's why I put them in that order. So what we need to do next is create a map. But instead of just using CartoPy to create a plain old map, I'm going to use the OpenStreetMap, which, if you're not familiar with OpenStreetMap, it is a open source, free to use map of the world, really. So if we zoom in here on Denver, we can see that there are lots of features. We see the toll roads, we see the airports, we see the individual streets. And if you really zoom in, you even see individual building addresses. So it's a very detailed open source map, much like Google Maps. So we're going to use that to create our map, and to do that we're going to get the image tiles using the CartoPy IO image tiles object. So first let's do some imports, of course. I'm going to import CartoPy's coordinate reference system as the CartoPy coordinate reference system. I'm going to import CartoPy.io.image_tiles as CartoPy image tiles. For Matplotlib toolkits, the axes inset locator, I'm going to import the inset axes object. So it's going to let me create axes for each of these windrose plots inside my main axes, which is the map plot. Next, I'm going to need to define my minlon, maxlon, minlat, maxlat for the Denver metro area, which I'm going to use -105.7, 104.5 degrees west, 39.5 degrees north, and 40.3 degrees north is my bounds. Next, I'm going to make a projection, and given that I am using these in just plain latitude and longitude, we'd call that plat Curie, or I don't have a projection. And then we're going to create a figure using plot.figure. I'm going to go ahead and set the fig size to be 12 by 8. And next we need to create an axis. Now you can create axes different ways. I generally like to use add subplot. It also lets us easily specify the projection. So I'm going to call this my main axis, and I'm going to call the add subplot method on my figure object. I have one row, one column, and I'm working on the first figure, hence the 1, 1, 1. And I'm going to set the projection to be my proj, meaning that we'll plot in latitude and longitude coordinates. For my main axis, I'm going to call setExtent for minlon, maxlon, minlat, maxlat. And we need to specify the coordinate reference system that those are in, and they are in latitude and longitude. So again, that's just going to be Plat Curie, which we have defined as proj. I'm going to go ahead and add some grid lines. I'll specify draw labels to be true, so we get labeled grid lines there. We could add things like coastlines and state lines, but we're really looking at a very small area here of the Denver metro area. Next, we need to get the OpenStreetMap tile object. So I'm going to call that request. The CartoPy image tiles .osm for OpenStreetMap. And then we need to add that image to our main axis. So I'm going to, on main axis, call the add image method, pass it our OpenStreetMap image tile request, followed by the scale. And the scale, a scale of 2 would be a very coarse scale, such as you're plotting global data. Maybe you're plotting lightning strikes around the world or earthquakes around the world. You would use a lower scale like that. If you're plotting something like a neighborhood scale phenomena, you might use a scale of 14. In this case, we're going to use a scale of 10, which is good for metropolitan areas. It could go a little bit lower, but this will show us a fair amount of detail in terms of roads and landmarks that we might be familiar with. Okay, if we run that cell as it is now, we get this map. So we've got our grid lines, and they're labeled, and we have the background map of the area. It looks about the right resolution to me. We can see the topographic relief of the Rockies. So this is a good start. Now we just need to add our Windrose data. To do that, we're going to have to define how big we want these windroses to plot, and then create inset axes for each one. So looking at the map, I'm going to say that I want the windroses to be about 1/10 of a degree. I think that would look fine. So I'm going to create a height in degrees of 0.1. And now we need to write a loop to go across all of our stations. So for station, in my stations list, first thing we need to do is get the location of that station. So the lon and lat, I can look in my locations dictionary using station as the key and use Python's handy unpacking syntax to get those as 2 distinct variables. Then I need to get the station data. So in my data frame, everywhere where the station data series is equal to the name of my current station. Okay, now I'm going to create an inset axis for the Windrose. So I'm going to call it Windrose axis. It is going to be inset into my main axis object. The width is going to be 100%. The height is going to be 100%. This is of my bounding box, so I want to use the entire thing. I'm going to go ahead and line wrap here. My bounding box to anchor is going to be the longitude of my station minus the height of the plot in degrees divided by 2. So I'm basically getting the corners that I'm going to anchor this axis to. The latitude of my station minus the height in degrees over 2. And then the height in degrees is going to be my width and height. The transform that we're going to use for this bounding box is not relative coordinates, but we're actually using the data coordinates, or the lat and lon from the main axis. So we're going to use mainax.transdata. And finally, since we're using a specific type of axes, a Windrose axes, we need to tell it that the axes class is Windrose axes. Okay, so that creates the axes, and now we can plot the data on that axis. And this is really going to be pretty much the same as we've done up here. There's nothing really all that different. We're still making a bar plot and setting a title. The only difference is going to be the name of the axes. It's now Windrose axes. So on the Windrose axes, we want to create a bar plot using the direction and the speed and knots values. We're going to norm them, and we want to make them red. We're going to set the title to be the station name. Maybe go with a little bit smaller font size since these are inset axes. And let's see how that looks. Oh, and that's telling us that we forgot a comma here, and we'll correct that spacing. A few minor typos to fix up there. And this is going to churn away, and we get our inset axes. So we have the stations at their location. And this is really pretty good, except I don't need all of this annotation in terms of the ticks, the percentage as my radial rings, and north, east, south, and west. I don't really need all of those. We can turn that off using Windrose axes.tickparams. Label left is false, and label bottom is false. This is normally for the left y-axis and bottom x-axis, but we're repurposing them here in the Windrose axis object for our wind directions and the either wind speed or percent of values if we're using a normed. Now when we plot that, we have a much nicer plot. This is a figure that you could present pretty easily in a paper or at a conference, and it's all done with really not that many lines of Python thanks to some amazing open source resources like the OpenStreetMap and the hard work of CartoPy developers. I hope that you found this useful, and I'll see you on next week's MetPy Monday.